Hello guys, welcome back to SAP2000 video tutorials. In this video tutorial, we will go through wind load analysis on a rigid diaphragm. So first I'll just create my model. I'll have 1, 2, 3, 4. Let's say 6 by 6 by 3. And since the units are in inches, so in X direction I'll have 15 feet, which will be 15 multiplied by 12, nothing but 180. Similarly, in Y direction I'll have 180. In Z direction I'll have 10 feet. So let's say it will be 120 inches. And the first grid line location will be at 0, 0, 0, nothing but origin. Select OK. Okay, so you have in this way. What we can do is we can reduce few of the grids. I'll just go to edit grid data. I'll say modify or show system. I'll delete that, and even that should be good. Delete that and that. Okay, now I need one more Z4. I'll make sure it's primary, show it. That's good. You just need to double click it in order for the options to come up. You select OK, select OK, and your grid is changed. Fine. Now, as you know, this is plan view, nothing but XY view. So I'll just go first. I'll define my materials. Let's say I have 5000 psi concrete. Select OK. And also, 5000 is good. Select OK. Now go to define. Let's make frame sections, one for beam and one for column. I'll say select concrete and I'll select rectangular. So beam will be looks like, let's say 12 by 12 for now, and select 5000. Select OK. Next add. I'll just copy this and say column, which will be 24 by 24, and select OK. Now that I have my columns and beams, I'll draw my columns and beams. So go to frame element, select column, draw it for each level. So now select all those, just go to edit and replicate. In X direction we add 15 feet, so we'll say 180 inches. Total number we want 1, 2 and 3. I'll say 3. Select OK. Now that this is done, select all of them, go to edit, select replicate. Now that will be y direction. So I'll say 180 in y direction. Make sure x is 0, and also we have total number of 3 in y direction. Select OK. So now your columns are done. Next we'll go for beams. Oh, I did something else. Okay, I have beam over here, so let's select from here to here to here. There. Now select your beams, go to edit, replicate, and in Z direction it will be 180 now. Zero in Y direction. Select OK. Oh, Control Z. It was because in Z direction we have only 10 feet, so we need to replicate it for 120 inches, not 180. Okay, we just needed to just delete that. Now I'll select all the beams. Okay, select all the beams, go to edit, say replicate, Y direction 180, nothing but 180 inches. Select OK. So you have your beams now. Okay, now what I'll do is I'll have a wall on this side, like in the center, and I mean in the center on all the sides actually. So before that I'll go to define section properties, area sections. I'll define my wall. I'll say shell thick 12 inches is fine. Select 5000 psi. Select OK. Select OK. Now you can go to this rectangular area section, and instead of, yeah, since this was the one I created actually, just model your walls. Now you have this, you can see it in extruded view. There you go. Now I'll apply on this side. These are nothing but your walls. So we are in plane 1 right now. I'll move upwards. See, number 2, now in number 3, and right now in number 4. So I'll draw the rectangular area. Now once I'm done in XZ, I'll go to YZ, and in YZ let's see where are we. Okay, we are right there. Now we'll draw it like this. Oh shit. Control Z to undo your action. Now just move your box so that it goes towards the end. Now again we'll draw our walls. Okay, this looks good. Next thing is I'm gonna do is I'm gonna have a area section. Let's see, where are we right now? Okay, we are at the top level, bottom, first story. Fine. From here to there, then moving up in the list, there to there, again moving up in the list. Okay, now you can view in extruded view if you want. Go to display options, select extruded view, select OK. There you go. So this is just a simple structure. Usually you will have your own plan, own structures. You will have your own loads. I don't have beams in this direction, I need beams in that direction. So let's go to YZ, and since we are in YZ, okay, I need on this side YZ. I'll have beams in this direction too. Select frame element, beam, Alright, now you have selected your beams. Let's see. Okay, we have selected on those extremes. So I'll go to edit, I'll say replicate. Now I'll replicate it in X direction. So select this as 0. This will be minus 180 because we are going in negative direction. Select OK. So it's, since you have the beams over here, so we are going in this direction, so nothing but negative X direction. So you have your beams over there, which is good. Now the only thing remained, actually let me just select the oh my god. Alright, this looks good. Okay, I just wanted to select those node points. As you see, I have selected all of those. Now I'll go to assign. I'll say joint restraints. If you want your moments to be transferred to your column, to your footing, you select fixed, or if you don't want, then you say pin. So in this case I'm gonna have it transferred, so I'll select fixed joints, I'll select OK. Now I have fixed connection, like fixed joint everywhere. Okay, now I'm going to the define load patterns. You have dead. If you want, we can add live, or else there is no need for now because we are doing wind. So I'll just add wind. I'll say type as wind, and auto lateral load pattern will be ASCE 710. There you go. I'll say add new load pattern. Then you go to modify lateral load pattern. So in here you select exposure from extents of rigid diaphragm option, and you make sure that this is 0.8 and 0.5. So in inward direction you will have CP coefficient as 0.8, and in leeward direction you will have your CP coefficient as 0.5, and even here you have your eccentricity ratios. These are your cases basically, so we'll say create all cases, and I'll have my wind load as 108 mph, exposure type will be B, and these are my gust factor, topographical factor, and directionality factor, which could be found from the code. I'll make sure that it is the exposure like wind pressure is calculated, program calculated. We'll come back to this window again. I'll select OK now. Select OK now. Now what I'll do is I'll go to plan view. No, I want 3D view in here. I'll stay as plan view over here. So where are we right now? Over there. That, okay. So I'm gonna select all the joints. Okay, now you go to assign, say joint. In joint you need to go to constraints, because we are gonna assign now a diaphragm constraint to the diaphragms. Since this is rigid diaphragm, like you have your load applied, like whatever the whole load of the structure will be acting at the centroid of the structure, nothing but center of the rigidity. So then from center it will spread to the shear walls, whichever we do. So for now I'm just gonna do the wind load analysis. Later on when we do RCC building and shear wall analysis, we'll go deep into the topic. So I'll select diaphragm. I'll say add new constraint. So my diaphragm 1 will be for my level 1, and I have level 3 levels. So I'll select OK, and then I'll add again one more. I'll select OK and one more. Now what I'll do is, so I'll just figure out where am I. I'm on level 1. I'll select all the joints. I'll go to assign. I'll say assign constraints diaphragm 1. Select OK. Now I'll move up the list, nothing but to level 2. I'll go to assign joint constraints. I'll say diaphragm number 2. Select OK. So now I'll move again up in the list. I'll go over here, constraints diaphragm 3. So that way you have different diaphragm constraints assigned to your joints, so that the load is transferred through whole of the structure. Like only a part of the structure doesn't have to take the load, it is transferred to all the members of the structure. So in assign, like in constraints, when you you didn't select this option. This option is selected when you have like multiple levels, like 10-20 levels, and you need to like you have different constraint for each rigid, for each diaphragm, like each level. It's because as the number of stories increases, like so the wind pressure acting from at upper stories, and when like let's say it's wind pressure at a story level 10 compared at story level 9, the wind pressure won't be, the difference between them, it won't be very much when compared to the loads acting on the diaphragm. So in that case you use like you assign a different uh, diaphragm constraint for each level. You select OK. Alright, now that you have done that, what I'm gonna do is I'm gonna assign some loads. Okay, let's, how should I do? I was just thinking like, let's go to this. Alright, we have selected a slab. I'll go downwards, I'll select slab, one more slab. Now I'll go to design, I'll say area loads, I'll say gravity in Z direction. Let's say how much do we have? We have kips per inch, kips per inch. Okay, let me just say it as PSF. That way it is easy to assign loads for me. Uniform shell, gravity, fine, say 100 PSF. Select OK. Now you have 100 PSF load acting on that area element. Now let me just select the members. Going little bit upper level, again upper level. Now going to assign, saying frame loads. Let's say distributed, dead 0. Nothing but, since we are in pounds, PSF 25 PSF should be fine. Select OK. Now if you see in this, you can view your loads, frame loads. You have dead. Alright, I need to remove extruded view. There you go. Now if I wanted to see area loads, I'll go over here. I'll say gravity direction, select OK. There you go. 100 is the max load acting on the slab. Okay, fine. Now you have assigned your diaphragm constraints to all the nodes, nothing but joints, and the load will be like transferred to all the members of the building. You can go to define, you can see in load patterns, different wind load patterns have been created for you. So in wind, in modify load pattern, you have case number 1 right now, like we created with all the cases. So in this wind you have case number 1 at an angle 0. If you go to number 2, if you see over here, you have 90 degrees Again case 1, select OK, go for number 6. Let's see over here, 90 degrees, case number 2. Number 5 with eccentricity ratio 0.15, case number 2, 90 degrees. So that way you have different load patterns. Like in rigid diaphragm, like you don't have to apply the CP ratio, like CP coefficient for wind pressure, like in windward direction and leeward direction separately. It is going to take care of those on its own. So now that you have applied your loads, let's just run and see. So you have your load patterns. So this is going to take a little bit of time since we have many number of load patterns. Okay, I need to save this. Wind load analysis, rigid diaphragm. And there you go, here your deformed shape. These are for different load patterns, like as you see, wind 3, wind 4, wind 5. And that's for dead. So you can even see your animation that way. So let me select this window, select perspective toggle, and now since I have deformed shape, I'll go for wind case 1. Do we need to see deflection? It will be in UY. Select OK. Now you can start the animation. Oh, it's in that direction. So let me go back to deformed shape, say UX. So as you can see, this is like very small, nothing but 30 to the power 30 multiplied by 10 to the power minus 6 feet. Let me convert that into inches. So 350 multiplied by 10 to the power minus 6 inches. So as you can see, it's moving in that direction. Now you can change it. You are different wind load patterns. See there. So apart from that, you can even see your axial force, shear. You can even see the values if you want. There you go. Even moment. And let's see if you have shells. Let's see for wind load. Alright, select OK. So yeah, max and minimum occurring over there. You can see 0.055 is max and 0.055 is min. Similarly for all the load cases, you can watch it. And let's do even concrete design. Oh, it's gonna take time because of the total number of load patterns. Well, you see most of them are failing because the load is very high and the beam members are 1 feet by 1 feet, which is really less. And as you see this, all the stress ratio values are greater than 1. Usually it should be less than 1. Now you can see like it says all the concrete frames pass the stress capacity check. See, like it's failing in shear and in everything, like because of the load is very high. Anyways, this we'll do it in the next video tutorial. Like we'll do a RCC building and we'll apply all the loads, all types of loads, combinations, and we'll actually design the columns and beams for it. And also we'll do the slab. Anyways, that will be all for today. Let me okay, that will be all for today. Thank you guys for watching the video. If you have any questions, please comment below. I'll be happy to reply. Thank you.